Good morning. In this video session, I would like to discuss about curvilinear kinematics. Now, what is the difference between linear, rotary, and curvilinear kinematics? Kinematics means without the cause, we are estimating the velocity, displacement, and acceleration. In the linear, we have only one vector in x direction. In rotary also we have only one vector perpendicular to the plane of rotation, z axis. Now in this curvilinear, the path of motion is some arbitrary in x, y and z direction. So the displacement vector is equal to x1 I plus y1 j plus z1 k. x1 in terms of t, y1 in terms of time, z1 in terms of time. Similarly, we have velocity vector, that is d s by dt or dx1 t by dt I dy1 t by dt j dz1 t by dt k. Similarly, acceleration also d square x1 by dt square plus I d square by 1 by dt square, like that. But if you observe this curvilinear motion, the velocity is tangential. At any point, the velocity is tangential to the path of motion. But the acceleration is not tangent because it is having some vector in some direction. This is velocity v vector and this is acceleration a vector. Now, in the curvilinear kinematics, we have two types of acceleration component. One is tangential acceleration, AT, and another one is normal component, AT, tangential we can say plus A N N, where T and N are unit vectors. So that means the analysis is going in this way. First, displacement will be given for in terms of t. Say time t is equal to 5 seconds, 10 seconds, 20 seconds, like that, from the beginning of path to the end of the path. You are going to determine the velocity at that particular time, acceleration at particular time, and also we are estimating the tangential acceleration and normal acceleration. So the question is how to determine this tangential acceleration and normal acceleration. So that is what is called curvilinear kinematics. If you determine the tangential acceleration and normal acceleration, you will get the acceleration vector. This is equal to acceleration vector. That means the magnitude of at square plus an square, because magnitude of this and is equal to the square root of a x square plus a by square plus a z square. That means at this point we are having three components of acceleration that we will get here, that is d square x1 t by dt square I plus d square y1 t by dt square j d square z1 t by dz square k. So that's the acceleration. So that means this two-dimensional, this is a acceleration having two vectors, tangential vector and normal vector. Same the acceleration having three vectors, ax square, ay square, dt square. So this is what is all about the curvilinear kinematics. And if this path is circular, see the same thing is there. Now, for example, this is Earth and this is Moon. Okay. Now the Moon is moving with some velocity tangential to the path of the Moon. This is velocity. Okay. And it is having some acceleration A. Now the displacement is circular displacement, velocity is tangential velocity, and acceleration is something different from the tangential. So this acceleration will be having normal acceleration, radial acceleration. Radial, because this is circular path and this is radius. Now here the normal is the radius of curvature is different. The normal is indicating the radius of curvature, and here the normal is indicating the radius of the path. So ARI plus ATJ or ATI plus ARJ. So this is the acceleration. Now, why we are trying to determine this acceleration is in kinetics. If you understand the kinetics part of this particular exercise, you are trying to determine centripetal force and centrifugal force. Now, centripetal force means what? That means because it is moving towards inside, the force is towards inside, that is centripetal. The centrifugal force means towards away. So here uh, alpha is alpha t is a tangential acceleration unit vector t plus omega square r radial vector acceleration. This is the acceleration vector. Alpha t is the angular acceleration. Omega square r is the radial acceleration. T is the unit vector and this vector. So the centrifugal force m omega square r, the mass of moon into omega square r is the radial force. Inertia of moon into alpha t. This is a tangential force. So these two it comes under kinetics, and this particular simple, the acceleration is kinematics. So the displacement, velocity, and acceleration, and this is a curvilinear kinematics. This is all under curvilinear kinematics. Okay. So this is what is about the curvilinear kinematics. We can have several video sessions on different types of problems that will come in kinematics part. So a satellite moving around the Earth, it will be having, the satellite will be having some velocity and acceleration, and it is displacement. How many hours, for example, 5 hours of time, how much distance the satellite will cover. That is a definition of the problem. And what is the speed required to uh, move the satellite so that it is exactly seeing a particular region throughout the orbit. So this all comes under, I mean, the satellite problems will always comes under the curvilinear kinematics. So this is what I would like to discuss, something about this curvilinear kinematics. Thank you for watching the video.